All right, so geometry, this is your transformations review, okay? So this is all of the sections, 9.1 through 9.3 and 9.6. These are all transformations. So what I'm going to do right here is I'm just going to review all the rules with you, and then we're going to go into the delta math and just do problems. And again, it is impossible for me to do every single type of problem because you're going to see that some of these involve compositions, which is two transformations in one problem. So again, there's a lot of different combinations now that we have translations, reflections, rotations, and dilations all talked about. So let's talk about translations first. So in all of these cases, we are starting with a point x comma y. That's our starting point, and we want to know what happens. Well, if you go a units right, you're going to take your x and you're going to add a. If you go a units left, you're going to take your x and subtract a. If you go a units up, you're going to take your y and you're going to add a. If you go a units down, you're going to take your y and subtract a. So there's your translation rules. Okay. Next are your reflection rules. I'm going to go back to capital letters because I think I write better in all caps. All right, so we have the x-axis. So when you do the x-axis, what's going to happen to your point xy is that your x will stay the same, but because you're flipping across the x-axis, you're going vertically flipping, your y is going to become opposite. So this is going to be the opposite of y. When you do the y-axis, now you're going to flip left to right because the y-axis is vertically. Now your x becomes opposite and your y stays the same. When you go across the line y equals x, this is exactly as it says. The y becomes the x becomes the y. And when you do the line y equals the negative x, your two numbers switch places and they both become opposite. Okay. All right, next is our rotation rules. All right, so again, assuming that we're starting with a point P at x comma y, all right? So let's do rotations in blue. So for rotations, we have 3. Okay, so your first one is 90 degrees counterclockwise. So what's going to happen is when you turn 90 degrees, the x and y switch and the first coordinate becomes opposite of yx. When you go 180 degrees counterclockwise, so the x and y now switch back. So they switch 90 degrees, now they switch back, but they're both opposite of x, opposite of y. And when you go 270 counterclockwise, now your x and y switch, but now the second coordinate is different. So y opposite of x. And again, remember that 90 degrees, 270 counterclockwise is the same as 90 degrees clockwise. So remember that. And for 180, you can go counterclockwise or clockwise and you get in the same place. Okay. All right, and last but not least is your dilation rule. So when you do a dilation, so if your scale factor is equal to n, then your point xy becomes n times x and n times y. So there's all your rules. So again, I'm going to go through these different problems. Sometimes I will use these rules and sometimes I'll just use the graph. So again, part of these transformations, which I think you've seen, is that you got to kind of see it. You got to see that it's turned. You got to see that it's flipped. And again, that can be tough. All right. Okay. So let me get that first problem up on the board. Okay, so here's the first type of problem. So again, this is a transformation on a single point, mixed. So you're going to have all of them available. So this says, what is the image of the point -1, -2 after a rotation 180 degrees counterclockwise about the origin? So again, remember, for 180-degree rotation, x comma y becomes opposite of x, opposite of y. They stay put. So both of these numbers will stay put, but the x will become positive and the y will become positive because that's what's opposite of a negative. 1, 2. Oh yeah. Let's do another one of these because they're quick. All right, so this one says, what is the image of -12, 4 after a dilation by a scale factor of 1/2 centered at the origin. So again, what happens with dilations? Your x comma y turns into n times x and n times y. You just take your numbers and multiply them by the scale factor. So we're going to take -12 and times it by 1/2, and we're going to take 4 and times it by 1/2. And that'll give us our new point of -6, 2. And there we go. All right, next problem coming. Okay, so more use of the rules. So now we're going to do a true compositions using a point. Now, I have to say this right now very, very clearly. When you do compositions, listen to me very carefully. You work right to left. That is very, 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 very important. This circle right here stands for composition. You must work right to left. What do we typically do? We typically read left to right. I get it. But with compositions, you have to work backwards. If you don't, you will get it wrong. So if you ask Michelle, I can't do this problem, I'm going to say, are you working right to left? And you're going to say, no. I'm going to say, then you're doing it wrong. Okay? All right. So the second transformation happens first, and then the first transformation happens second. That's all I can say. All right. So the first thing we're going to do is this translation. T stands for translation. 5, -2. So that means we're going to take our x's and we're going to add 5. Oh, we're going to add 5. And then to our y's, we're going to subtract 2. So take your point 8, -9, and add 5. And then take -9 and subtract 2. So after the first, so this is the first transformation. After the first transformation, our new point is 13, -11. Great. Now we're going to do the second transformation. We're going to rotate 90 degrees. So remember, when you rotate 90 degrees, the two coordinates flip and the first coordinate becomes opposite of what it is. So you're going to take these two numbers, you're going to flip them. So the -11 is going to come first, but the -11 is going to become opposite. The 13 goes second and it stays the same. And that should be your new point, 11, 13. Very cool. We'll do a couple more of these because these are very interesting problems. And again, I have to emphasize right to left. All right, let's take a look at this fun problem. So it says, what is the image of point -4, 6 after the transformations of r, y equals x, composition with r of 180? So again, we have to work right to left. So we're first going to do this rotation, and then secondly, this reflection. Now again, uh, I think that in the textbook they explain this differently. So I apologize for that. But I hope you understand that when they give you the degree measure, this capital R means rotation. So again, I think this is backwards from our textbook. I apologize. And then this lowercase r with the line means reflection. So hopefully that doesn't confuse you too much. All right, so let's do this first one here, rotate 180 degrees. So when you rotate 180 degrees, your point xy becomes opposite of x, opposite of y. Again, just look at the rules that we talked about at the beginning. If you chose not to write them down, then you know what? Go back and rewatch that and write them down now. Okay. So the -4, 6 are going to both become opposite. 4, -6. That's the first transformation. And then the second one here is going to be the reflection across y equals x. What happens when you go across y equals x? The x becomes y and the y becomes x. They just switch places. -6, 4. There we go. And that's our new point. Notice that we still use the two numbers 4 and 6. We just kind of change them around. The only time you're not going to use the same numbers are when you do a translation, because you actually slide, so you add or subtract something, or a dilation because you're going to blow up or shrink. All right, so be aware of that. All right, let's do one more of these on this video. Nice. So let's take a look at this one. So it says, what is the image of point 4, -12 after the transformation of a reflection across the x-axis and then a dilation by a scale factor of 1/4? So again, we work right to left. So the first thing I will do is this dilation. So remember, with a dilation, you simply take the coordinates. So in this case, 1/4, you take the 1/4 and multiply it by the x. You take the 1/4 and multiply it by the y. So 4 times 1/4 is 1. So 1/4. So we're multiplying both of these by 1/4. And negative 12 times 1/4 is negative 3. Okay, and now we're going to reflect across the x-axis. So remember, when you go across the x-axis, that means you're flipping vertically because you're going across a horizontal line. So your x stays the same, but your y becomes opposite. So your x of 1 stays the same, but your y becomes opposite. It's already negative, so opposite of negative is a positive 3. Very good. Cool. So these are very much coordinate related problems. These are great problems. Make sure you focus on these. Awesome. Next video coming up talks about more transformations graphically.